So during this portion of the presentation, we are going to be talking about the grazing potential and economics of planting and then grazing these oats after corn silage and high moisture corn harvest. So why did we choose oats for this fall grazing system? Well, it's because in small cereal grains, winter sensitive species produce a higher yield in the fall compared to winter hardy species such as rye. And since oats is a winter sensitive species, we chose it due to its high fall production. And in these two pictures, we're looking at our two different grazing treatments. So on this left side of your screen, we have oats planted after corn silage harvest. So cattle that were stocked to this treatment, they received only oats, and their stocking rates were calculated based off of oat yields alone. And then if you come over here to the right side of your screen, you'll see oats planted after high moisture corn. Cattle that were stocked to these treatments received what little oats there were in addition to corn stover. So their stocking rates reflected those two feedstuffs. So just to keep in mind. So here's a look at our own oat timeline. You can kind of see what happened and when it happened. So in late August or early September, oats were planted after corn silage harvest, and fertilizer was applied at planting or soon afterwards. And then in mid-September, oats were planted after high moisture corn harvest, and again, fertilizer was applied at planting or very soon afterwards. And then we came in early November, and this is when we took our oat biomass samples, and we used these samples to estimate total oat yields. And then these numbers were then calculated or used to calculate stocking rates. And these stocking rates, for these stocking rates, I should say, we assumed 40 pounds of dry matter per day per head with a very low harvest efficiency rate of 40%. And we assumed a 70-day grazing period, so that'll give you an idea of what we stocked for and what we were trying to achieve. And then in mid-December to late January, depending on how many days the cattle were able to graze or utilize their grazing pastures, cattle were pulled off during these times. So this is just a visual to give you an idea of what a turnout day might look like. And this happened to occur in 2016, which was our highest oat yielding year. So this is just an idea of, we'll give you a visual comparison of the two treatments. So some oat specifics, horsepower oats, we used horsepower oats seeded at 96 pounds an acre with a 7-inch row spacing, no-till drill, and urea fertilizer was applied to deliver 40 pounds of nitrogen per acre. The cattle that were used, they were grazing steers that weighed about 485 pounds, and these animals were allowed to graze until weather or oat biomass limited their intake. And so that will kind of explain how their pull dates varied between about a month's worth of time. And then in their stocking rates for cattle grazing oats after corn silage harvest, they started off at 1.7 head per acre, and it ranged down to 0.6 head per acre. And then stocking rates for after high moisture corn harvest, they ranged from 1.4 to 0.07 head per acre, and they averaged about 1.1 head per acre. And I just want to point out that over the years, these gradually decreased. So that'll just kind of give you an idea. And I just would like to point out again that the stocking rates for the cattle grazing after high moisture corn, we accounted for oats plus stover. So that is why these two stocking rates are fairly similar, just to keep in mind. This graph, with this graph, we are looking at the oat yields on the two treatments, and they are in pounds per acre. So the yellow bars represent high moisture corn oat yields, and then the green bars represent the corn silage oat yields. And then obviously the numbers on the bottom represent years, and these numbers in the middle, these are the number of grazing days that we were able to achieve during those grazing seasons. And so the first takeaway from this graph would be oat yields were always lower for high moisture corn than they were corn silage, and you can see that. Except for in 2018, you can see that the bars are a little closer together. And just a little background for the audience. In 2018, the oats that were planted after corn silage harvest, they failed, so we had to come in at a later and obviously less ideal planting date. So these oats after corn silage in 2018, they did not have as many grazing days as many growing days as they should have. So that's why those bars are a little more closer together. And then the second and probably the biggest takeaway is the number of grazing days was not dependent on oat yields. And why is this? Well, if you look in 2016, it was our greatest oat yielding year, but we only got 42 grazing days out of it. And if you come over here to 2019, which was our lowest was our lowest oat yield, we received our greatest number of grazing days. So the two aren't really related, but what we look at during this time, in 2016, there was an ice storm, which caused the cattle to be pulled prematurely. So that affected their number of grazing days. And then in 2018, heavy precipitation caused muddy conditions, so the cattle were trampling in most of their oats, and so that caused them to also be pulled prematurely. So just to highlight those two things. And then up there in the corn that just popped up, these were the oat yield averages, just to give everybody an idea. Corn silage oats yielded about 2,400 pounds an acre, while high moisture corn oats yielded about 945 pounds per acre average. So in this graph, the first thing that we're going to address, we can look in these two columns that I've got highlighted. They are the average daily gain of cattle grazing oats after corn silage, and then they are the average daily gain of cattle grazing oats plus stover after high moisture corn harvest. So the first bullet on this sheet, we addressed that cattle grazing after corn silage always had greater gains than cattle grazing after high moisture corn. And we can attribute that to the oats after high moisture corn. They always had smaller yields, and they always had smaller yields. And so that caused them to not graze as long. And also, this is what I was trying to think of, pardon me. The oats after high moisture corn, it was the design of the study, the oats were meant to be a supplement to the corn stover, but instead cattle tended to go out there and eat the oats first thing, and so they would limit themselves to only corn stover in the end. So their average daily gains in the beginning, when they were receiving a lot of oats, their average daily gains probably looked a lot better, but as they went throughout the season and continued to limit themselves on oats, this also had a negative impact on their average daily gain. And then the next thing that we would be looking at on this graph, we are looking at their weather conditions. So in this first column, it is the percent of grazing days with precipitation. So for example, cattle in 2015, they spent about a third of their time with precipitation occurring. And then this far column on the right, it is the percent of grazing days at or below 32 degrees Fahrenheit. So to use 2015 again, these cattle are spending about 37% of their time at freezing temperatures. But what we're going to conclude from this graph is that precipitation has the larger impact. While both precipitation and cold temperatures do have an impact on cattle gains, we are going to assume that precipitation played the major role in determining cattle performance. And you can so just to give you guys an idea or something to think about, cold temperatures will impact the way that cattle utilize energy, but it will not cause as large of an impact as a wet hair coat will. So that's just something to think about. And then again, precipitation events such as rain and ice and snow, which caused muddy conditions, or it caused the cattle to have no access to their food. Those were the instances that we had to pull cattle from. So that had a major impact on how long they grazed. And then just at the bottom, just another average to get everybody on the same page. The across the years, the average daily gain for cattle grazing after corn silage was 2 pounds a day, compared to high moisture corn cattle, which averaged about 0.9 pounds of gain per day. This is just a visual to show you a precipitation event that would have caused us to pull cattle off of their pastures prematurely. And then we move into our economic analysis. So during this analysis, we are considering the expenses on the left hand of your screen, which consist of oat seed, custom drilling, fertilizer, fencing, and cattle transportation. And we've totaled all these up and put them on a cost per acre basis, and then we were able to roll this cost over to cost per head, depending on how many animals we were able to graze in that pasture that year. And then we would roll that on over to cost of gain, which is on a per pound basis, once we analyze cattle performance data. So here we are looking at the cost slide, and the first thing we are going to look at is the total cost per head. So in total cost per head for corn silage, it ranged from about $40 to about $101, averaging about $71 for cost per head. And then in high moisture corn, the range was about $60 to about $105, averaging about $77 in expense per head. And then we'll go down here and we'll look at cost per gain. And cost per gain numbers in the corn silage system, they range from about 46 cents to $2.56, averaging about $1 for every pound of gain. And then in the high moisture corn system, the range was 78 cents to $2.70, and they averaged about $1.80 per pound of weight gained. And so what's really important in the system is that you've probably noticed is that the expenses associated with the high moisture corn cost are, for the most part, greater than the expenses associated with the corn silage system. And that could be because of the, first of all, the high moisture corn cattle received an additional charge. We charged them $15 per acre in stover charge. And then the cattle grazing after high moisture corn, those systems, for the most part, also had a smaller stocking rate. So we had fewer head, to spread the expenses over. So, and then one thing to highlight before I leave again, I've already addressed that 2018 had to be replanted. So in case you saw this, I just wanted to highlight that these, the corn silage side, it had a greater cost per head during 2018, and we can attribute that to the cost of replanting and then the poor oat yield associated with that year. So we're going to move into profits, and just before we do that, I'd just like to say steer values were established before and after grazing in order to determine the value of gain, and we use numbers reported for Nebraska by the USDA to do these calculations. So here's our profit slides, and in our profit slides, we are combining performance, costs, and the market in order to determine these. So in profit per head, in corn silage, the range was negative $15 to positive $152 and then corn silage averaged about $106 in profit per head. And then high moisture corn, the range was negative $48 to positive $31, and we averaged about $7.42 in profit per head in the high moisture corn systems. So if we will go down to look at profit per acre, the range in profit per acre for the corn silage system, it ranged from negative 10 to about a positive $252, and it averaged $114 in profit per acre. And in high moisture corn, the range was negative 36 to positive 37, and so we averaged about $12.58 in profit per acre in the high moisture corn system. So as I just kind of talked about, in most years, both of these systems were profitable. However, you can see that the profits associated with the high moisture corn aren't very impressive, so we would not say this is an economically feasible way or grazing system. We wouldn't say that it's very profitable. And I'd also like to point out that the profits on the high moisture corn systems, we can't attribute them to them being a part of our grazing system. We were just able to catch the markets right. So we basically made profit for owning the cattle more than anything. So just to highlight a few things before we keep going, the factors that influence system profitability, definitely weather is the main driver because it impacts performance, and oat yield is also a product of the weather. And then stocking density. Stocking density allows you to, it gives you an option, it gives you a strategy to determine how many grazing days that you are aiming for, and then by that way you can kind of target where you want to hit in the market. So that would play a role. And then moving on to considerations. So if you're considering committing to one of these grazing options, you should make sure you have adequate growing. You should make sure you have an adequate growing period for your oats. And for this, we would recommend you planting no later than the first week of September. September 1st is really ideal for that. And then you should also make a decision based on what type of operation you're part of. So we are assuming that if you're a cow-calf producer that you are going to sell your animals. And so you might try stocking lighter in order to hold on to those cattle longer and to lengthen your grazing period in order to benefit from the January market. That would be a strategy for you. And if you're a feedlot person, you probably are not going to sell your cattle and you're just going to roll them into the feedlot after they're done grazing. So you might want to use a heavier stocking density in order to utilize your forage resources, but limiting or decreasing the number of days that they're out there in order to decrease your yardage fees. And then to the next bullet point, stocking densities, that would result from your operation type or your strategy. And then you could also think about some alternative systems. So if you have missed the oat planting date deadline, you may want to start thinking about later planting, and that would consider winter hardy species would be one of your considerations. And Dr. Drunowski is going to discuss that next, so I won't touch on that subject. However, we've already said that grazing oats after high moisture corn harvest isn't really economically feasible. And so we are going to look at supplementing distillers grains on corn stover as an alternative. So what we've done on this slide, we've used the same type of animal, same weight, and we've stocked them to corn residue. And then we've charged 8 cents, it's actually 8.5 cents, I'm sorry, per pound of distillers grains. And then we've targeted 1.2 pounds of gain per day. And we are targeting this gain over a 70-day grazing period in order to put on adequate gain but not jump weight brackets, because we're aiming for that January market and we don't want to get hit on the other end by having gained too much weight. So in order to accomplish these gains, we're going to feed 2 pounds of distillers grains per head per day. And so we come down here to this next line where we've done the math, and this is the cost of 1 pound, and then we times it by 2 pounds. So the cost of distillers grains is about 17 cents per head per day. And then we've also added on a 25-cent yardage fee for every head that's out there for every day. And then we add these up and it comes to 42 cents per head per day in charges associated with supplementing distillers. And these assumptions came from a pooled analysis about supplementing studies, and it was accomplished by UNL, and you could read about it in the 2017 UNL Beef Report if you're interested. And then since we're comparing the supplementing distillers back to we're comparing it to grazing oats after high moisture corn. So in this slide, what we've done is we've taken all these costs up, the seed, the drilling, the fertilizer, and the application, and we've determined these costs in over a 70-day grazing period, and we have determined it to be a 77-cent per head per day charge. And so when you compare these two systems side by side, you obviously can see that grazing oats after high moisture corn harvest, it costs more, and if you guys remember from earlier in the presentation, these cattle were gaining 0.9 pounds per day on average. And then if we look at supplementing distillers grains on corn stalks, it costs us 42 cents per head per day, and these cattle are gaining 1.2 pounds a day. So that is a very reasonable alternative system that producers may consider. So some conclusions from my portion of the presentation. Weather is the main determinant of system success. And then oats after early harvested corn silage is a viable and profitable system most years. And then we've said this numerous times, but grazing oats after high moisture corn is not a cost-effective grazing option. And then you should just always plan ahead, and whether that in that planning you should look at oat growth period, stocking densities, and just overall strategies to help you get to and accomplish your goals. So that is all I have in my portion. So I'd like to turn it over to Mary, and thank you all.